Determine the components of the support reactions at the fixed support A on the cantilever beam. Okay, so we have a cantilever beam, so this whole thing is called a cantilever beam, and here we have a fixed support. So remember, in a fixed support, the external actions are transferred into the fixed support in the form of an axial force, a shear, and a moment. So these are the support reactions, typically support reactions at a fixed support. Okay, so what we need to do here is to draw a free body diagram of this whole cantilever beam, 3 meter, and then up 1.5 meter. Okay, so here let's show support reactions in red. So we would be having a support reaction AX here at point A, and we would be having an AY here, and the moment. So this is moment A. And as for the external loads, we have a 6 kilonewton applied force here, and then we have like a 4 kilonewton applied load there. So that's my cantilever. Okay. Okay, so that's my free body diagram. Free body diagram with all the external actions like 6 kilonewton, 4 kilonewton applied forces, and the support reactions. Okay, so this free body diagram, we need to have an equilibrium for this particular system. So equations of equilibrium, right? Okay, so we need to write equations of equilibrium here. Okay, so the first equation is in the, so if we have this x and y axis system here, x here and y here, so the sum of the forces in the x direction, x being positive in this direction, should be 0, and hence we can write this. So we have two components here for the 4 kilonewton, that makes a 30-degree angle with the horizontal, so that's 30 degree. So we have here, let's draw the components with a different color here. Okay, so we have this component here and this component here in the x and y direction, so that would be cosine 30, and the other would be sine 30. So for the x direction, we have 4 times cosine 30 degree minus ax is 0, and we have here ax is 3.46 kilonewton. Okay, so that's ax. And for the sum of the forces in the y direction, y being positive upward, equals 0, and we will be having a positive ay pointing upwards, that's why it's positive, minus 4 times sine 30 degree, and minus, we have a 6 kilonewton here pointing downwards, so negative is 0, and ay is 8 kilonewton. 8 kilonewton. Okay, and for the moment, we have sum of the moments about a point A, so anti-clockwise direction is positive, assuming, okay, so we'll be having moment A. In the equation we have positive moment A minus 6 times, so that's 1.5 meters here, so that's 1.5, so 6 times 1.5, and minus the components here and the distances, so 4 times cosine 30 degree times the distance, so that's 4 times cosine 30, and the distance would be, so we extend this, that's the line of action of this, the x component of the 4 kilonewton, and this distance is, that distance is 1.5 times sine 30, okay, so that's 1.5 meters here, and sine 30 times cosine times sine 30 would be giving us this distance h, okay, so 4 times cosine 30 times 1.5 meters times sine 30, okay, and the other component is this one, 4 times sine 30 degree, and times the distance would be, we have a 3 meter here, so that's the distance of like 3 meter here, and plus this distance, this one, so 3 plus 1.5 meters times cosine 30 here. Okay, so that equation is equal to 0, and we find moment A equals 20.2 kilonewton meters. Okay, so here we have the reactions AX, AY, and moment A. Thank you for listening.